go. Hello, YouTube. I'm going to try and simplify what I was saying. I want to keep this nice and short. Let me just go over an overview. I'm first going to try to get you to understand why I think we were created in an environment that was far different than the environment we're in now. I think all of our creation happened in a very tight, very different environment. Second point would be that tight environment that we were created in, we are messing with something that is interfering with it. And I think that's what the Mandela Effect is about. Okay, I will reduce myself. I'll start talking about this. I'll try and make it a lot quicker so that we can get to how this is affecting, how CERN is affecting us. I believe CERN and other colliders, if they are creating even a small black hole, are affecting the information that we depend on. And it sort of comes to a different reality of how things are working. Anyways, let's just go through a few things and then you'll see what I mean. Reduced myself down. The Mandela Effect and Colliders, a connection. First, evolution and creation debates. The creationist came up with an excellent point. More time in random events causes a lot of trouble. It doesn't make things better for the evolutionists, it makes it worse. They make the point of a plane dropping cue cards, and it's going to spell, let's say, Mandela, nicely on the ground, maybe, let's say, 3 feet. For each letter, can't be any more than 3 feet, has to be fitting into a nice little spot, perfect spot. If you were to drop cue cards from a plane to hit that spot and to spell out Mandela, you are going to have, well, let's say we drop it at 1,000 feet. It doesn't work. Let's say then I raise that plane up to 10,000 feet because I want to get more time to organize. Let's say we're going to drop it down and it's going to organize, right? The more time I give it, let's say I go up to 10,000 feet and I'm hoping for it to fall into a tighter pattern, but I get a wider scattering. All right, let's say I go up to 100,000 and I will find that the scattering will be even greater. But if what I am trying to build is an ecosystem, and I'm going to start off with DNA, RNA, metabolic motors, I'm going to start off with all these things that are microscopic. I don't have lots of space. I have less space. Things are tighter. This comes up to point number 2, right up here. So point number 2, if I stop time, I have lots more room for random events. So let's create a stoppage of time so we can get down to creating life, because we don't have the kind of time we need. Well, in fact, when we do have the time we need to create life, things like UV rays start destroying it before we even get done. So more time doesn't help us. Stopping time is a huge advantage in creating life. Where in the universe can we look to stop time? It's actually a short list. What stops time? What's the one thing that could stop time, that could shorten time up, even stall it out? Black hole. Okay, you enter into a black hole, you're looking at information separating from separates from your matter. And this is called the black hole paradox. I just switched to the internet here. Let's see if I can move this. Oh, I almost had it. I'm going to move the box over. We're just going to Wikipedia and having a look at Wikipedia, what they say there. The information black hole paradox. And this goes back to the simplicity time of chemistry of France, where they would put in a tube, let's say water, they seal it in a thing, and if you applied heat to it, you didn't destroy the water. When it cooled back down, it would condense and you'd have the same amount of water. They did this several times over to prove a point that you cannot, you may degrade things down by the second law of thermodynamics. You can have degradation. You cannot have a loss of matter. You cannot have a loss of information. So let's go back over here to what I was talking about before. That's the separation I'm talking about. So a black hole will separate the information from matter. Now, I didn't bring it up, but NASA has talked about, they have discovered matter exiting a black hole. So, if matter can exit a black hole, I don't even need a lot of matter. And now, if you take that as a word of faith that matter can exit a black hole, that's a big leap there. Now, let's move on to number 6. Einstein's spooky action at a distance. Now, one of the things I remember about spooky action at a distance is the entwinement of molecules. The entwinement of two atoms, when they become entwined and you separate them and move them apart at a distance, when you turn one, the other one turns. And they both sort of share you turn one way, the other one will turn the same way. It is an odd behavior. Let's bring this down to my next one here, which is information. I'm suspecting, my belief is, the two atoms share the same space. The same space of information. Imagine matter exits a black hole and it's entwined into the information. And when you entwine two atoms, you entwine them to the same spot of information. How does this have anything to do with CERN? Imagine CERN is doing this collider and other colliders are doing the same thing, and as they push it up, let's suppose for a moment that you do hit a black hole. You hit so hard that you're actually able to create a black hole, even for just a fraction of a second. Here's my theory. Because we know that all black holes have an information platter, an information sort of balloon around them. Imagine you created a black hole and it takes information. Alright, it takes information from where? Well, from our information. It's got to get it somewhere. Then the black hole disintegrates, it falls apart. Our information is not destroyed, but it is degraded. It means that it comes back to us, but not as in great as a shape as it started out. This is my theory. My theory is these colliders are slightly wrecking our information. Sounds crazy, but I think this is what we've done. A black hole, I think, is the hard drive of the information of what we are, and creating another hard drive, it will suck, because, well, suck or whatever you want to call it, it will grab from around its surroundings what it needs. Not even what it needs. It will just grab random stuff around it. That's what black holes do. I would very much expect that's what's happening. And that's why things are happening a little strange. That's why we have this Mandela effect. That's why we are seeing stuff that we know is switched and changed, but we don't know why. And that's all I have to say about the Mandela effect. Thank you very much.